Alright, so we're starting our review by making flashcards, and you're going to use these for the next few months to study. We're going to put our theorems and our vocabulary words and all of the most important information throughout the year. So let's start with theorems involving lines and planes. Now don't write on this top line, we're going to use that later on. So start on the second line. And this is the first theorem involving lines and planes. If a line is perpendicular to each of two intersecting lines, so if a line is perpendicular to each of two intersecting lines at their point of intersection, comma, then the line is perpendicular to the plane determined by them. Period. Alright. In the bottom left corner, just put a little 1. Okay, so, because we're going to number our cards, because we're going to need to find this card later on. Now on the back, let's draw a picture of what this looks like. Okay? So what we have is a plane, and you can draw this however you want. Okay, we just have to draw a flat surface on our paper. So I'm just drawing any flat surface. Okay, so that's a plane. And what we have is this, we have two lines, okay, inside this plane. So these lines are lying flat in the plane. Okay? What you could imagine is this, say this index card was the plane, you have two lines lying flat in the plane, crossing at a point. Okay? And then what you have is, where those two lines are crossing, you have another line coming straight up that's perpendicular to these two lines and to the plane. Okay? And that's what the theorem says. So now let's draw that line that's coming straight up from the plane. Okay? And it's also perpendicular to the plane. So what we draw is this little box, right? That means 90 degrees or perpendicular. Okay? So that's the picture for that one. Let's go to the second card, this next theorem. Through a given point, there passes one and only one plane perpendicular to a given line. Okay, let's go on the, this is number 2. So put that in the bottom left. Let's go on the back and draw a picture of what this looks like. Now I'm going to draw another plane, and again, it doesn't really matter how I draw it, so I'm going to draw this one kind of like upward facing. Okay, so there's our flat plane, and what we have is a line coming through this plane. So we got one side comes in front of the plane, and the other side is behind the plane at first until it gets to the edge, and then once it's at the edge, it comes out the back. Okay, so we have this line going through this plane, or this plane crossing or cutting this line, okay? And what I'm going to draw is another one of these perpendicular marks. So there's only one plane that is perpendicular to a given line at a particular point of intersection. That's what this theorem says. Let's go to the next one. Okay, give me a second. Through a given point, there passes one and only one line perpendicular to a given plane. This essentially says the same thing as the last one, but in reverse, but it means the exact same thing. And in fact, let's put the little number 3 down here. And in fact, it's the same picture. So I'm going to draw something similar to what I drew in the last one. Okay, there you go. Next. Oh wait, we got to draw the perpendicular mark. Okay. Next one. Two lines perpendicular to the same plane I like actually put the number 2 instead of the word. Two lines perpendicular to the same plane are coplanar. This is number 4. Okay. Now on the back, this picture is complicated, so take some time to draw this. Watch exactly how I do it. Okay, take your time. Definitely don't rush this one. This is a little complicated to draw. Okay. Let's see. Okay. Now, Okay. So what we have here is two planes crossing. Now I'm actually going to make these a little bit easier for me to see. I'm going to color them in. And you're going to do the same thing, because it makes it much more obvious what's going on here. And just color it in lightly. Don't take too much time to... Okay. Okay, so you see how that's like the first plane? Okay, it's cutting through one of the other planes. So I'm going to color in the other plane also. Use yellow on this one. And this will really make it stand out. Okay, so now you have a much better idea of what's going on than when you don't color it in. All right, we have one plane intersecting another plane. Okay, now you have this line in the middle here where they intersect, right? So when two planes intersect, it forms this line. So let's extend that line a little bit. Okay, so every point along this line, these planes are intersecting. And now we're going to draw the lines coming off of these lines are obviously lying inside that plane. Okay? And they're perpendicular. Alright, so let me just see the best way to draw that. Okay, I gotta go up at the same angle. I gotta go up parallel to this line to make it look right. So essentially something like that. Okay. So there you go. Now you can reread the theorem. Two lines perpendicular to the same plane are coplanar. So these two lines are perpendicular to this plane, so that means they must lie in their own plane, meaning they're coplanar. They lie in the same plane. Okay? Alright. So, and we numbered that? Yes, number 4. So we're on number 5. Oops, give me 1 second. Two planes are perpendicular to each other. if and only if one plane contains a line perpendicular to the second plane. Okay? Let's draw a picture of what this looks like. Alright. Again, take your time on this because it's a tough picture. As far as I'm concerned, it is anyway. It's tough for me. Alright. And we got this other line. Going a little lower. Okay. Now this comes straight down to here. And this one comes straight down to this one. This one comes straight down. This one comes straight down. Okay, so we have two planes intersecting again, right? So I'm going to go ahead and pretty quickly color these planes in again. Okay. Okay. All right, so now you see what's going on here. We have these two planes crossing each other, right? Now, again, there's this line going through, because that's where they intersect, right? They intersect right from here to here, and when they intersect, they form that line or line segment, okay? And we have this line laying in this yellow plane, okay? And it's perpendicular to this blue plane. Okay, so This is card number 5. Two planes are perpendicular to each other if and only if one plane contains a line perpendicular to the second plane. And that's what's happening in this picture. Okay? Let's do our 6th card. If a line is perpendicular to a plane, then any line perpendicular to the given line, so comma, then any line perpendicular to the given line at its point of intersection with the given plane is in the given plane. Okay? Let's draw a picture. Again, this is another one of those toughies, so just take your time. All right? Let's see. Should be getting a little better at this as we go, but not necessarily. Let's try that. Okay. Okay. Let's see. I actually am getting better at drawing this. Hopefully you are. Okay, same deal, right? Let's color it in since we've been doing that. It's working for me. Okay. It's making it much clearer for me. I don't know about you. All right. Okay, so there we have it. Now, I got that line again where they intersect, so I extend it a little bit just so it's clear to us. Okay, and I have this one line in this yellow plane. All right, and it's in the yellow plane, and then it goes behind the blue plane and comes back out the other side a little bit. So let me, okay, draw that. And then I have this other line coming through the blue plane. All right, and it also comes out the back just a little bit. Okay, you see that? And where these two lines meet, it's perpendicular. And the planes as well. So this is card number 6. And what it says that if a line is perpendicular to a plane, then any line perpendicular to the given line at its point of intersection with the given plane is in the given plane. And you can analyze that statement with this picture. It goes with it. All right. Essentially, it's almost the same picture as the last one. Now, we're on the 7th card. Let me just move my thing down. Hold on. Okay, if a line is perpendicular to a plane, then every plane containing the line is perpendicular to the given plane. Okay. So, again, we have a picture similar to what I've been drawing, so we're going to keep drawing it that way since I'm doing pretty good at it. Okay. Again, I'm gonna color mine in. Okay. Now, for this picture, we have essentially something pretty identical to the last one. We always want to draw that, extend that middle line out a little bit. Alright, now we have this line in the middle of this yellow plane. Okay. And that's all we have. And it's perpendicular. It's always a little confusing for me on how to draw that exactly. Perpendicular to the blue plane. Because it says if a line is perpendicular to a plane, see that line is perpendicular to that blue plane, then every plane containing the line, you see how the yellow plane contains the line, is perpendicular to the given plane. So then these two planes are perpendicular also. Okay? Not a big deal. And that was card, well, let's put it in the bottom corner, that was card 7. Okay, let's do our 8th card. If a plane intersects two parallel planes, remember the symbol for parallel? That's the symbol. If a plane intersects two parallel planes, comma, then the intersection is two parallel lines. Okay, now let's draw. This one is the toughest one to draw. Alright? So, let's see. I gotta take my time here. Okay. Now, okay. Well, it's not going to come out that great, but it will come out okay. I hope. Alright, I think I'm almost there. Oh, it came out not big enough for my card, but that's okay because we'll still be able to see what's going on here. Drew it too big, but not a big deal. So this plane is just coming off the page a little bit. Not a big deal though. Alright, so you see what's going on here? I have two planes intersecting another plane, so I'm actually going to go ahead and color those in also. Okay, maybe it's a little clearer what's going on now, right? Two planes are intersecting that plane, and these two planes are parallel. So, well, first of all, let's just draw those extension lines a little bit. Right, that's where they're intersecting the two planes. Okay. So, this is card 8. If a plane intersects two parallel planes, so these two yellow planes are parallel, and then this blue plane came in and intersected them, okay? And what that says is when that happens, the two lines that form the intersection lines are also going to be parallel. So if these two planes are parallel and it's intersected by a plane, it will form two parallel lines. That's what this theorem says. All right? And we have one more planes and lines theorem. The 9th one. Okay? So we say if two planes are perpendicular, to the same line, they are parallel. And this picture is a little quicker. Okay, what we have is two planes right next to each other. So I'll draw the first plane. And we don't have to color these in because I usually only do colors when we have intersecting planes, and here we're not going to have intersecting planes. Okay, so we do still have two planes though. Side by side, essentially. Okay? something a little longer than that. Okay, so we have this line coming through these two planes. So it's coming through here, and then it's behind the plane to here, and then it's again behind this plane. So hopefully you see how that works, right? Okay, and also it's perpendicular to those two planes. So, doesn't matter. If two planes are perpendicular to the same line, they are parallel. So these two planes are perpendicular to the same line, you see? So then those planes are parallel to each other. They're right next to each other, like this, exactly parallel. Okay? Those are, oh, we got to put a 9 down here. All right, so those are the 9 theorems involving lines and planes. All right, now we're going to write down some note cards about prisms here. So a prism has 2 parallel faces. Called bases that are congruent polygons. Okay. The lateral faces are rectangles in a right prism. Or parallelograms in an oblique prism. In a right prism, the joining edges and faces are perpendicular to the base faces. Okay. A prism which has a parallelogram as its base is called a parallelepiped. Actually, we don't even need that, so let's not even put that. Sorry guys, too specific, too specific. Not necessary. Okay, so this is card number 10. Let's go on the back. And let's draw a couple of pictures. Okay? First, I'm going to draw a picture of a prism. Just one type of prism. There are many types of prisms. I'm just drawing one. I'm drawing a right triangular prism. Okay? And then this side you can't really see, so hopefully you realize how we draw this by now. We draw it with a dashed line. Alright, now okay, so this triangle on the bottom here right, and this triangle on top here, those are called the base, or the bases. Okay? And then you have these sides, right? Which are rectangles in a right prism. This is a right prism, straight up and down. Okay. So really you have a front face, you have one in the back, and you have one on the left side. So these are the lateral faces. Okay? And this is what's called a right triangular prism. Okay? Now I'll draw two more prisms that you're probably somewhat familiar with. Okay? I'll draw it as best I can. We're going to make that extension a 1/2 inch. So something you're all familiar with. Now this line's got to be dashed, right? Okay, so here we have a right rectangular prism, right? And again, these top pieces, we can call those the bases, and everything else, which really is covering the whole entire thing, except for the top. All the sides, essentially, except for the top and bottom. They're called the lateral faces. I'm not going to actually write that down. And then this dimension right here, right? That's what we would call the height. Okay? So, now let's also draw underneath here an oblique, what's called an oblique prism. See how it's at a slant? That means it's an oblique prism. Okay. So again, those would be the bases. I should have actually drawn them in blue since I did that on the other one, but it doesn't make a difference. Okay? And this is all the lateral faces. Okay? So let's just identify the bases. And now my height is the vertical distance. Okay? So the distance straight down, in other words, another name for it, which is the altitude, this is my height. Okay? And this is what's called an oblique triangular prism. All right? So that's the main ideas for the prism. Let's put that aside. Okay, it's going to sharpen this. Now let's get into more of the specifics about what's so important about prisms. What do you have to know besides that about prisms that's crucial? And really there's a few things. Just give me 1 second here. Alright, that was card 10, so now we're on card 11. Alright. And I just need a minute to look this up. Exactly how the wording goes. Alright, here we go. Okay. Here we go. The edges of the prism where the lateral faces intersect are called its lateral edges. Okay? The lateral edges in a prism, now this is very important right here. The lateral edges in a prism are congruent I'm going to use the symbol for congruent. Are congruent and parallel. Okay, so let's draw a picture of this on the back. Okay, now let's see if we could draw this shape here. Let's see. I'm using 1 inch as my mark here. So I'm drawing, what I'm going to draw is a pentagon, and I'm going to make all of its sides 1 inch. Well, about 1 inch. I mean, it's not going to be exactly. Okay, and it doesn't have to be. I mean, because the top definitely isn't gonna, it's gonna be a little longer, these top pieces. And that's fine. Okay, so there's the first part of my prism. That's one of the bases. Okay, now I'm going to extend, let's see, this is the farthest point here. So I'm going to extend each one of these lines 3 inches and at the same angle. But some of the lines have to be dashed because they're in the back. Like this one right here. This one's going to have to be dashed. And so is this one. And I'm making them all 3 inches just to make it easier for myself to actually draw this shape. And I'm making them all parallel because that's one of the things that we just learned, is that all these are called the lateral edges, what I'm drawing right now. They're all parallel. So now this line has to be dashed because it's in the back. This line right here is in the back, so it has to be dashed. Let's see. Try and keep this line is solid. Sometimes the shape starts reversing on you and starts getting a little crazy looking. That's solid, and this one is going to be dashed. Okay. So, all right. Now, I'm going to highlight the lateral edges in blue. I'm going to identify them. Lateral edges. And now the lateral edges are all congruent. So they all get one of those congruent marks, right? And not only that, but they're all parallel. So they all get one of those feather marks, which means parallel. And if you don't remember that, you got a lot of studying to do, because that's something you should not have forgotten, either one of those things. So all of those edges of a prism are parallel and they're all congruent. That's something that's very important to know about a prism. So when we look back at this, these are the lateral edges. See how they're parallel and they're the same length. Same thing here. These are, let me just check something. These are the lateral edges in this one, right? They're all parallel and they're all congruent. And then here, these are all the lateral edges of the cube. They're all parallel and they're all congruent, okay? And that goes for any prism. All right? Now let's put our next important concept about prisms. This is note card 12. Okay? Let me just check something. Okay. So, the next thing about prisms is about the volume of a prism. So, the volume of a prism is the product of the base area all right, and I'm going to underline base area because that's where everyone makes a mistake. The base area times the height of the prism. Okay, now let's see. So V equals BH, where V is the volume, B is the base area, and H is the height. Okay? Now, let me go on the back and draw a picture of this. Now I'm going to draw a simple triangular prism to demonstrate this. I'm going to make each side about 1 inch. Not that that matters, but that's what I'm doing. Okay, and then I'm going to extend my lateral edges 2 inches. So now everything that every other lateral edge should be 2 inches and should also be parallel. And then this one, of course, is behind the prism. And now I just connect this. Has to be dashed because it's behind the prism, and this one also has to be dashed because it's behind the prism. Yeah. Okay. So now this is the important part here. The base area is the area of one of these bases. Remember, there's 2 bases, right? The 2 triangles in this case. So this is B, the base area. Okay? And this distance here of the lateral edge is, okay, so again, this whole surface, right, this is an area, so B is not a length, B is not like the distance of this line, B is the area of the base, okay, it's the base area, and H is the height or the length of the lateral edge, okay? So that's the next most important idea about prisms. Alright, we're on card 13, the next card about prisms. And the next important point about prisms is that if the base area, which remember is B, and the height / altitude, because they mean the same thing, which is H, of 2 prisms are the same, comma, then they will have the same volume. All right? So let's see how I want to draw this. All right. First I'm going to draw a rectangular prism. I'm going to make the sides 1 inch. I'm making the lateral edges 1.5 inches, just in case you want to do the same. And remember, this one we have to make dashed. Okay. Okay, so this is a rectangular prism. Right, and then our distance from here to here, the lateral edge distance, which is our height or our altitude, so let's call it h sub 1, and we'll call it the height, and let's call this capital B sub 1, which is the base area of this shape. Then the volume of this shape, let's call it V sub 1, would be B sub 1, H sub 1. Now let's draw a rectangular prism. Okay, so now I'm drawing a rectangular prism. Ooh, that's not right. We have to go to this corner here. Okay. Okay, let's call that surface area B2, and it's the base area of this shape. Okay, and let's call this H2, which is the height or the altitude of this prism. And then the volume of this prism, V2, we'll call it V2, it would be B2 times H2. Okay, so now what we're saying with this theorem is that if B1 equals B2, so if the base areas are the same in these two prisms and the heights are the same in these two prisms, then V1 would equal V2. Then the volumes of the two prisms would be the same. Okay? So that's what this theorem says, and it's an important one. Okay? And that's number 13. Okay, this is